Lesson 12.6a, the law of cosines and the law of sines, and this will be the last video for geometry. This lesson is going to introduce two important theorems that can be used to determine the sides and angles in oblique, either acute or obtuse triangles. So we can use trig ratios and theorems to solve triangles that are not right triangles. Basically what we do is drop altitudes in the triangles and make right triangles to do this. The general acute triangle ABC, has side lengths of A, B, and C. This is the triangle we're used to seeing. And each opposes its corresponding vertex. That means that angle A is across from side A, and angle B is across from side B, and angle C is across from side C. In this case, the measure of angle A will now be written, for the most part, simply as A. The law of cosines can be used to solve missing measures of a triangle when given two sides and the included angle, or all three sides. So you can use the law of cosines when you have two sides and an included angle, or all three sides. And the identity is derived using the P theorem and a basic trig ratio. So let's take a look at an example of that. We have a triangle, ABC. It is not a right triangle, but it does have acute angles. We are going to drop an altitude, BD, and we form two right triangles by doing so. We have the first triangle, which is C squared, using the P theorem, equals x squared plus h squared. And then we have the that equation that we just created, and for x squared let me strike that. We're going to use both of these triangles. So for the first triangle, A, B, and D, we'll have c squared equals x squared plus h squared. For the second triangle, we'll have a squared equals b minus x squared plus h squared. So for each side, we will use whatever information we have and substitute it into the P theorem. We can now solve, and we can expand our equation. So let's go ahead and square this b minus x, and we end up with b squared minus 2bx plus x squared plus h squared. So we end up with the trinomial b squared minus 2bx plus x squared, and then we still had plus h squared in the original equation. So that's expanding the squared binomial. We now have the trinomial and a term. Now if we go ahead and sub c squared for what we have in red, the x squared plus h2 squared, we can now have a very usable equation. So we have a note here, and this note says that x, this x right here in the equation, actually equals c times cosine A. And x sorry, had to correct something there. So we have x equals c cosine A, which leads to x cosine A equals x over c. This is just by rearranging the equation, and this is actually being used in the next step here. So we take step number 4 where we sub the c squared for x squared plus h squared, and we now have b squared minus 2b, and instead of x we have c cosine a plus c squared. We substitute the c cosine a and we rearrange. And now we can go ahead and state the final equation by rearranging again, and we have a squared equals b squared plus c squared, which is something that you are used to seeing, minus 2bc, 2 times bc times cosine a. And what does this bring us to? Well, this equation right here is the law of cosines, and this is how it's derived. Now, this isn't something that you have to worry about, but just know where it comes from. We've taken a regular triangle, dropped an altitude, created 2 right triangles, and by combining and substituting these different values, we end up with a final equation. So, for any triangle ABC, so here's our standard triangle. A squared plus equals b squared plus c squared minus 2bc cosine a. And as we did in a couple of previous lessons, we can actually derive 2 other laws just by rearranging some of the sides. So if you're solving for b squared, it will equal a squared plus c squared, and the 2bc will convert to 2ac. You'll be solving for cosine b instead of cosine a. So when you're solving for b, you'll also have cosine b in your equation. When you're solving for a, you'll have cosine a, and with c squared, solving for c, you'll have cosine c. Now, this is not an error. When you see this, both of these will be 2ac in this part of the equation. So let's apply this. In example 1, find a in triangle ABC if the measure of angle A equals 57 degrees, B is 6, and C is 9. So this is SAS. It's 2 side lengths and an included angle. So we know that we can go ahead and use this law of cosines. And because we're solving for A, we'll go ahead and use the expression we learned back here to find A. And we'll have a squared plus b squared equals b squared plus c squared minus 2bc cosine A. And now we substitute the values that we know about. So let me begin drawing and show you where these are. So b squared, b would be the side across from b is 6, so we'll have 6 squared. And c squared is a side across from c, which is 9, so we'll have 9 squared. And 2 times b times c, so we have b again is 6 and c is 9. Now the cosine 57 comes from cosine angle A, and we merely are going to substitute the degree measure into the letter of the angle. So we have cosine 57. And if we solve, 6 squared is 36, 9 squared is 81, and 2 times 6 times 9 is 108, and cosine 57 is 54.4639. Our next step is to combine by adding, and then we should multiply first, and that answer is in parentheses, and then we should combine by adding, and then we'll subtract. and we end up with an answer that's approximately 58.2. But remember that we're solving for A, and doing something, circling or boxing or highlighting might help you remember that. And A will be 58.2, the square root of 58.2, which is 7.6. Example 2. In this case, we're going to solve for C. So we'll use the equation from the slide that showed us C squared equals A squared plus B squared. And I just noticed that I had that wrong on the law of cosine slide, so I corrected it. So if you took notes on this, what C equals, changed that. It said C squared, should have been B squared. Minus 2AC times cosine C. And let's take a look at our triangle. The side opposite A is 5, so it would be 5 squared. And the side opposite B is 6, so this will be 6 squared. And we will have 2 times A times B times cosine 78. And this will be approximately 48.5. So if C squared is 48.5, the square root of 48.5 is approximately 6.97 or 7.0. If you're finishing at this point and you were just going to state the side length, you would say 7.0. But we're actually going on to solve an angle, so you'll use the 6.9 because we're not finished with the equation. So it also asks you to solve for this C is 6.97. They want us to solve for the measure of angle A also. And then the measure of angle B. So what you can do, it says all 3 sides are known. Used a rearranged form of the law of cosines to solve. So if you have all 3 sides, you can use this equation. And we're going to start with cosine of angle A. And we're going to use this to solve for, to help solve for our sides. So cosine of angle A is B squared plus C squared minus A squared divided by 2 times B times C. I'm not going to derive that for you. That's actually from a previous lesson. But you can just use this. I will tell you in the homework which equations to use and give you a good idea of how to use them. So let's substitute known values. B was 6, so we have 6 squared, and C was 6.9, so it's 6.97 squared, and A was 5, so that's 5 squared. And B here was 2 times 6, and this looks a little strange. My parentheses is the wrong way. Let's fix that. And we divide, and we end up with approximately 0.7121. So we're going to use this value to help solve for the measure of angle A. So the measure of angle A equals cosine -1, or is our inverse of our cosine, times 0.721, and that is approximately 44.6. So that's the measure of angle A. And we had already solved for our side. And so now the measure of angle B will be 180 minus 78 minus the 44.6. Now you wouldn't use the 90 in this case because this is not a right triangle. So you would go back to the 180. And the measure of angle B will be 57.4. Now I realize this is a long problem, but like I said, I'll be walking you through the homework. So let's move on to the law of sines. This is the second theorem in this lesson, and it says for any triangle A, B, and C, and here we have three sides, three ratios of three sides, and they're all stated that they're equal. So in a triangle, and we've talked about this before, your sides will have the same ratios in a triangle. And those ratios might be sine over sine A, example, over side A. So this is the angle over the side, angle over the side, angle over the side, or you could have side over angle, side over angle, side over angle, and you can see the pattern. So your pattern will be sine A will always be over side A, and side C will always be over angle C, and so forth. The law of sines can be used to solve triangles when two angles and any side are known. So if you have AAS or ASA, the law is derived by dividing each expression in the SAS area theorem that we learned by 1/2 ABC. In example 3, we're going to find the distance from each tower to a fire. And I believe what they actually say in example 3 for the problem is this. A ranger in a fire tower spots a forest fire located 53 degrees south of east. So here's your 53 degrees. Another ranger in a second fire tower located 12 miles due east reports sighting the same fire at 45 degrees south of west. Find the distance from each tower to the fire to the nearest tenth of a mile. So we're finding the distance from the each tower to the fire. The fire is point C. So you sketch a triangle. A is the first tower, B is the second tower, and C is the fire. And let's find the third angle first. And we do this by subtracting the other two angles from 180. And our third angle is 82 degrees. Now we use the law of sines, and we have our side over angles. And we only need two ratios, because we know if we have two ratios equal, the third will also be equal. So if we use the information that we have, we'll use A over sine 53. So side A over the angle across from it, which is sine 53. And we'll use 12 miles, because we want to be able to use our length, over sine 82. And if we go ahead and multiply these and create an equation, we set to A, we end up with 12 sine 53 So A equals 12 times sine 53 divided by 82, and that's approximately 9.7. So this length right here, A, this side will be 9.7. Now, we're going to solve for B in the same way with the law of sines. So we have B over sine B, and we'll use C over sine C because we have that value. And we'll have B over sine 45, so B is over the angle 45, and we'll have, once again, the same ratio that we're equaling B to, which will be 12 over sine 82. And if we multiply across, we have 12 times sine 45 divided by sine 82, which is 8.6. So we have now solved all three angles and all three sides. Your homework lesson is problems 1 through 12. And I'm going to give you hints for all of them. So in homework problems 1 through 2, and here's an example of number 1. We find C, so we're looking for C. You'll note that we have the other two sides, and we have at least one angle in between the two sides. So we're going to use the law of cosines that applies to side C. So we have C squared equals A squared plus B squared, and we're going to subtract 2AB cosine C. We substitute our known values in there, and we go ahead and solve, and we end up with approximately 5.6. So side C is approximately 5.6. Now when you do number 2, it's identical to this problem, but you're finding B. It's similar to example 1. You'll have a different triangle, and your equation will be B squared equals A squared plus C squared, subtract 2AC times cosine B. So all you have to do is do the substituting and do the work. Numbers 3 through 5. We're going to do some problems like example 2 to solve. So you'll use cosine B for number 3, and this is the equation you'll use, A squared plus C squared minus B squared divided by 2A squared. Once you have that answer, then you'll solve the measure of angle B by multiplying the answer from the first step by cosine -1. And number 4, you're using cosine C. Here's the equation. You'll solve, and then you'll substitute the answer for the measure of angle C. And number 5, you'll use cosine A, then solve for the measure of angle A by using the answer and multiplying by cosine -1. Numbers 6 through 9 will be similar to example 1, and number 6 will use this equation. B squared equals A squared plus C squared minus 2AC times cosine B. Number 7 will use example 3, and here is the equation that you will need to use to solve. You do not need to solve an angle for this one. You're just going to solve for a side length. The same for number 8, just a side length. Number 9, you'll solve for a side length and for an angle. And your last 3 problems, 10 through 12, solve for the side length A with this equation. Number 11, you'll solve for B and angle B. And here is your equation. And then your last problem, you'll find side C and the measure of angle C. So if you have any questions or concerns, please contact me. If you want me to double check an answer for you to make sure you've gotten it correctly, please contact me also, and I'll try to get back to you as quickly as possible.